This is a spike protein. It's what gives the coronavirus its unmistakable look. And scientists think it may be the key to why new variants of the virus are becoming more transmissible.
We begin tonight with the alarming rise in infections fueled by the highly contagious Delta variant and the sobering words from Dr. Fauci warning today things are going to get worse.
The Delta variant was first detected in India last October, where it helped fuel a devastating COVID surge. It has since spread to more than 100 countries.
The big concern is that with more transmissible variant, you have more cases and you have more chance for super spreading events and epidemic surges, which overwhelm our healthcare systems.
Here's the science behind why these new variants are spreading faster and what this could mean for vaccines. Like other viruses, when the coronavirus replicates, small genetic mistakes or mutations can occur.
You can be almost certain that as long as there's a lot of virus circulating in the community, there will be the evolution of mutants because that's what viruses do.
Many of those do nothing. Some of those actually confer a survival benefit for the virus to transmit more effectively, for instance.
Abrar Karan is a global health physician who has been studying the coronavirus pandemic.
And so as it does that, it has a better chance of spreading to new hosts and continuing to replicate in those hosts.
Karan says this is likely what is happening with the new, more transmissible variants appearing around the world. Recent research has shown that a number of these new versions of the virus have mutations that affect the spike protein. Take a look at this model of the coronavirus. You can see each spike protein is made up of 3 identical parts known as protomers. These protomers have the ability to change their position from closed to open, affecting how easily they can bind to and infect human cells.
You could visualize it like a flower. So you've got petals on the outside, the really obvious thing that you see. There are 3 of them. The 3 of them have to bind to the receptors.
Jeremy Lubin is a virologist who studies the coronavirus. He explains that when the protomers are down, infection is more difficult. But when these parts are up and open, it's much easier. In the first version of the coronavirus that originated in China in 2019, these protomers usually had a closed shape, which may have made it less transmissible than some more recent versions of the virus. This is another view of the spike protein that helps to show where these mutations occur. In the winter of 2020, one mutation known as D614G emerged. It appears in this region of the spike protein and has been present in various variants since, including Delta. This mutation made it more likely for the spike to have an open shape, increasing the virus's ability to infect human cells. Soon after the mutation emerged, variants that had it took over.
So by June, pretty much all the viruses around the planet had this change, this mutation. Our belief is that it supplanted the original virus because it was more transmissible.
Another element that affects the spike protein is antibodies. These are proteins that defend the body against the coronavirus by blocking the ability of the spike protein to attach to cells, which prevents the virus from infecting. Antibodies are produced by the immune system in response to infection or vaccines. The new coronavirus variants that scientists are worried about also have mutations that affect the spike protein. This includes the highly transmissible Delta variant. This variant has a number of mutations that scientists think could be affecting its ability to spread. One is called T478K. It's in a region of the spike protein that's involved in how the virus binds to receptors on respiratory cells. Another mutation that scientists are focusing on is called P681R. It's located near a part of the spike protein that helps the virus enter and infect cells.
What the antibody recognizes is a shape. If you're playing with blocks and you have triangles and circles and you have to fit them into the appropriate holes, you can't fit a circle into a triangular hole. It's analogous to that. If the virus then changes so that it's no longer a triangular hole, but it's a circular hole, then the antibody will no longer fit.
Scientists have also found that some coronavirus variants have parts missing in a region that comes off the side of the spike protein. This is known as the N-terminal domain.
Some of those mutations are removing surfaces of the protein that other antibodies bind to. If the virus mutates that surface or deletes it, those antibodies are no longer going to work to block the virus.
Scientists say this may help explain why vaccines may become less effective against some new variants. This is why experts are urging caution.
Variants are going to continue emerging, and we need a public health strategy that addresses it. Vaccines will be a major part of COVID control for the foreseeable future.
Experts continue to emphasize the importance of getting vaccinated, along with other strategies to keep transmission low and stop the spread.